Good day, everybody. I'd like to welcome you to today's webinar. Today, we will be discussing the benefits of high voltage lithium-ion batteries. I would like to introduce the team for today. My name is Mohammed Sidat. I'm the Technical Sales Advisor for Fronius South Africa. Fronius South Africa is an agency of Fronius International. I'd also like to introduce my two colleagues from Fronius International. They are Subra Nicolo, who is the Technical Sales Advisor for Western Africa, and David Mwangi, who is the Technical Sales Advisor for Eastern Africa. I would then also like to introduce Ivan Holdsworth, who is the Technical Support Manager for AfriPlus Energy Group. AfriPlus Energy Group is the official service partner of BYD for Southern Africa. Having a look at today's agenda, we will start off with battery storage chemistries. We will then have a look at architecture and chemistry of a cell. We will then move on to an overview of lithium-ion chemistries. We will then discuss the durability of lithium-ion chemistries. Moving on to the lifespan and second life applications, differential characteristics. Then why should you choose lithium-ion phosphate batteries? And we will then hand over to Ivan from AfriPlus, who will then go through the BYD premium lithium-ion phosphate HVS/HVM batteries. Starting off with battery storage chemistries. Okay, so currently you do get a few different battery chemistries that are available on the market. Just to name a few, some of you may be quite familiar with, for example, lead acid and lithium-ion batteries, which are actually the most popular batteries for PV systems. But then there's also other batteries on the market, such as sodium sulfur batteries, and these are very common in stationary applications. Also, we have batteries such as nickel cadmium, which is very popular to be used in power tools. Okay, so since this is a solar webinar, we will primarily be discussing or comparing, let's say, lead acid batteries with lithium-ion batteries. Okay, so discussing lead acid batteries first. The advantages are it's robust and reliable. It has very good investment costs. However, they weigh quite a bit for their power outputs. They suffer from outgassing, forced air circulation, very low cycle stability. Again, also very low lifespan, and they also have a lot of maintenance. Remember, whenever you do use a lead acid battery, you have to make sure that you always run a fully saturated charge, which can take about 14 to 16 hours every few weeks, which you don't necessarily have to do with lithium-ion batteries. Okay, moving on to lithium-ion batteries, just to discuss a few advantages. So they have extremely good high cycle stability, no memory effect, less weight, very safe, high lifespan, high system efficiency factor, high voltage, and no maintenance. Okay, the only negative is investment costs for now, in brackets. Again, as many of you do know, is the price of lithium-ion batteries are continuously dropping as you know the technology becomes more and more advanced. And again, with lithium-ion batteries, you have extremely good energy density. Moving on to architecture and chemistry of a cell. So with a battery, you get three sort of characteristics, let's call it that. So the first one is the cell chemistry. So this is the actual active material in the cell. Okay, then you get cell architecture, which is basically the structure of the cell. For example, is it a cylindrical cell or is it a pouch cell? Thirdly is the battery management system. And this is also extremely important because this controls the system down to the cell level, and it basically controls the charging and discharging of each cell. again, if you have a very good battery management system, you can get extremely good performance out of your battery. Okay, so if you have really good 3 characteristics of a battery, it can lead to extremely good overall characteristics of your battery system. You can basically achieve extremely good useful time, which can lead to a prolonged lifespan. You also get extremely good cycle stability with a good number of charging and discharging processes. You also get a good buffer against calendar aging, which is aging process on cell level. And you also get extremely good C rates. Basically what a C rate is, it's a charging and discharging rate of a battery. Having a look at the different cell architectures. So basically what I have over here is we've got the BYD battery box, HV. We also have what we call the LG Chem battery. Okay, and then we also have a Fronius solar battery. With our Fronius solar battery, we used to sell it to the market before, but I think we've stopped for the last 2 or 3 years producing this battery. But anyways, when we did produce the Fronius solar battery, we basically used the cylindrical cell topology, and this gave 3 amp hours output per cell. Okay, if you're looking at the pouch cell, which is the cell that's actually used in the LG Chem battery, this has about 36 amp hours per cell output. And then if you move on to the prismatic cell, which is the cell which is found in the BYD battery box, this gives an output of about 60 amp hours per cell. So you can see on a cell level, the prismatic cell is again the overall winner from these 3 batteries. Again, with BYD, this is our solution partner moving with the new hybrid inverters from Fronius, which is the Gen 24 Plus inverters. And we see them as the most suitable partner for our storage applications moving forward. Moving on to battery system design. So what I have over here is a BYD high voltage battery. So basically what this is kind of composed of, if you look at the little black box over there, that's actually the battery management system, the BMS system, which controls each cell. Okay, we then have these gray boxes, which are basically the battery modules. And inside each battery module, we have about 16 cells in series. Each cell is about 3.2 volts. So if you take 3.2 volts and you multiply it by 16, because they are in series, we'll get about 51.2 volts. Okay, the cell capacity is 25 amp hours. And because they're in series, the overall output for this battery module will be 25 amp hours. Your usable capacity, again, it will be 1.28 kilowatt hours per module. Now moving on to an overview of lithium-ion chemistries. So in terms of the catalog of different requirements, probably the most important aspect any homeowner or installer will look at a battery is probably the cost. So cost in euros per kilowatt hour, we'll have a look at that. We'll also have a look at the safety, the lifespan of the battery, the energy density, okay, which is usually measured in watt hours per kilogram, the power density, which is usually measured in watts per kilohour, the discharge characteristic, which is your depth of discharge, your self-discharge, operating temperature, which is extremely important to prolong your lifespan of a battery, and your overcharge and over-discharge protection. Okay, so I basically have a little shape here which kind of indicates and points towards all the most important factors in the battery. Okay, such as specific power, which is measured in watts per kilogram, your safety in case of failure, performance at different environmental conditions, your lifespan, your cost based on energy, as well as your specific energy, which is measured in watts hours per kilogram. Using these 6 definitions, we can kind of class a battery technology in order to see where it would be most beneficial to use, and in which case scenario it would be the best option to make use of that battery technology. Okay, so which lithium-ion chemistry is best for our application? So if you start and look at the different topologies we have, starting with lithium cobalt oxide. Okay, if you do use a lithium cobalt oxide battery, you can get extremely good specific energy. However, this is kind of compromised on the safety and the specific power, okay, and also on the lifespan. If we, for example, look at a lithium manganese oxide battery, again, we get decent safety, decent specific power, specific energy. However, this is compromised on performance. Okay, if we now move on to lithium iron phosphate batteries, we can actually see this is where the lifespan is actually the greatest amongst all these battery technologies indicated on the screen. And also the safety factor is extremely good, again, which is very, very beneficial for solar PV storage systems. Again, you always want to achieve the highest lifespan from the battery, and because this battery will be installed in your home, you also want to make sure that this battery has the highest safety as well. Okay, with lithium iron phosphate batteries, unfortunately, one area that they do sort of not perform too well is on the specific energy. But then again, if we do have a household installation of a PV system, space is not really an issue. Okay, unlike an electric vehicle, for example, where space might be more of a topic, or maybe a mobile phone, where you can't really have a big battery inside because the phone will then be too heavy. Okay, you can then also have a look at the other battery technologies, but basically in a nutshell, if you look at the best lithium ion chemistries on the market, it basically comes down to two: lithium iron phosphate batteries and lithium nickel manganese cobalt oxide batteries. Okay, but then if you look at the safety and the lifespan, this is now where the lithium iron phosphate is pretty much beats the NMC batteries. Okay, so having a look at today's best lithium-ion chemistries. Okay, so on the top here, we've got your anode material, okay, and the bottom, we have your cathode material. As you all know, in a battery, your anode and your cathode are your two potentials, and this is pretty much how the electrons flow. Okay, so if you look at your anode material, since we are dealing with lithium-ion batteries for this presentation, we can see that we get extremely good energy density. Okay, but now if you look at the cathode material, for your lithium iron phosphate, this is now where we pretty much beat all other technologies on the fact that we can achieve the best performance for cost per amp hour, stability, safety, power density, compared to these other different battery technologies. Okay, so you can see again with safety and stability with lithium iron phosphate batteries, you can pretty much ensure that your installation is safe as well as stable, which again is very important for residential PV systems as well as for commercial PV storage systems as well. Okay, I'll now hand over to my colleague, David, who will now take you through the durability of lithium ion chemistries. David?
Right, so thank you so much, Mo, for the first exciting part of the presentation. I do believe we had a poll to launch, so probably before I go on, you can do the poll, then I continue after that.
Yes, yes, I will launch a poll now. I'll just really appreciate if everybody could just share your input. But yeah, the first poll we will launch. So I'm sure everybody can see it now. Yeah, so which battery voltage systems are you most familiar with? So either low voltage or high voltage. Again, low voltage on the DC side, we specify as being between 12 to 48 volts. High voltage on the DC side, we pretty much specify anything plus 100 volts. Okay, thanks for sharing your inputs. I'm just going to share the results now. Okay, so you should see the results on your screen. Again, pretty much the entire audience has experience with low voltage systems, which is very understandable because this webinar is for the sub-Saharan Africa region. And in sub-Saharan Africa currently, the more popular topology between low voltage and high voltage is low voltage, due to the fact that in the past, in order to get hold of a high voltage battery was not very easy. And also there were not many high voltage hybrid inverters on the market. So in sub-Saharan Africa, the market is actually very saturated with low voltage hybrid inverters. So again, with our Gen 24 plus inverter, we're going to kind of change this. And now with BYD being available in sub-Saharan Africa, we're going to see a gradual shift from low voltage to high voltage. Okay, so David, if you can please continue.
Okay, thank you. So we will now be looking at the lifespan and second life applications of different batteries. But in this particular webinar, we are going to play more emphasis on the lithium iron phosphate batteries, because this is our point of discussion today. So every battery, of course, whether it's the normal lead acid or the new technologies involving lithium iron phosphate, are subject to aging, and this aging will be affected by two major factors. So factor number one that definitely will affect your battery, whether it's in operation or not, is what we call the calendar aging. So, and calendar aging basically refers to the design lifespan of the battery. So it could be in a shelf somewhere just sitting, but because the active materials have been put in the battery, whether it's in use or not, that will definitely have an effect on how long this battery can be used. But most importantly, the battery aging process is mostly affected by what is called cycle aging or aging by usage. So, and this definitely depends on the battery chemistry. So looking at most commonly used battery chemistries, especially the lead acid, where we have a sulfuric composition inside as the electrolyte, that is not as stable as a lithium iron phosphate battery that is using an ether constitution as the electrolyte. So the depth of discharge also becomes very important. We are going to see much later on how this is affecting also the efficiency of the battery, and therefore the choices you make in terms of which battery technology to go for. As we know already, the lithium iron phosphate batteries have very good stability when you go into deep cycles of discharge. And therefore you can achieve something like even 80% DOD, whereas most even good quality lead acid batteries are limited to 50% DOD. So in terms of the durability of the batteries, there's already long-term experience for lithium iron phosphate batteries, because these batteries now have been used in motor vehicles for quite some time, also in mobile devices such as phones and tablets, as well as laptops. And therefore, most manufacturers right now are able to give warranty guarantees or periods of up to 10 years, as we have with BYD currently. When you're looking at roadworthy use of these batteries, some of them are actually extending up to 240,000 kilometers. So, and at this period, after this duration of usage, we still have about 70 to 80% of the usable capacity still in the batteries. So this experience already has been achieved by looking at different manufacturers as are listed here. So you can see the EGOF with an average of about 8 years or about 160,000 kilometers. And at this stage, the battery still has retained 70% of usable capacity, because this is quite important when you now talk about what is the second life usage of these batteries. So another battery technology that is out there, mostly used in vehicles, is the LG Chemuresu, with a throughput up to 80% of usable energy at around 10 years of service. In terms of what happens to the battery, depending on the applications. We have a scenario whereby we can consider second life usage of these batteries, especially when the battery was initially applied as an automotive battery. So in the second life of application, this kind of batteries can be used as stationary for stationary applications. And this we are talking about grid stabilization or even power backup applications, whereby we want to utilize the remaining 60 to 80% of the usable capacity still in the battery when it becomes not so viable for application in a motor or electrical vehicle. So in this graph here, we can see that when the battery is first utilized in an EV, we have starting from about 100% usable capacity up to about 80%, whereby the range of the motor vehicle coverage in terms of kilometers is not so nice. And therefore, at this point, most EV users are looking for a battery replacement. So this could be anywhere from 6 to 10 years of service life with this battery. But that does not mean that this battery is necessarily useless at this point. And therefore, there can be a symbiosis or coexistence between the automotive sector as well as the solar sector for standby backup applications. And therefore, these kind of batteries can, with a lot of ease, be utilized for different applications, especially as shown here, once it has reached 80% of usable energy. Until now, it goes all the way down to about 50% usable capacity in the battery, whereby now the battery can be argued to be out of service. So these are important considerations to make, especially now going forward, because these technologies will become more and more popular around the world. In some parts of the world, China and so forth, electric vehicles are very common, and therefore the market for second life application of automotive batteries is going to be here with us in not a very long period of time. So we can see some examples here of some second life application cases for grid stabilization, as I mentioned before. Also for backup power. So we have two applications here that you can check out on your own. So these are available on the internet. So Amsterdam Arena, as well as the BMW plant in Leipzig. So another important consideration when you're talking about lithium iron phosphate batteries is what happens at the end of life of the battery. So, and not only for lithium iron phosphate batteries, we are talking about all electrical and electronic waste. We must have a thoroughly thought out plan of how to recycle these batteries at the end of life. And therefore, working with strong partners such as BYD, who are very cautious and very concerned about the environment, we can be guaranteed that at the end of life, these batteries can be taken back to proper recycling facilities, whereby any active or usable components of these batteries can be put back into service by making new batteries or making other suitable electronic or electrical components. So we have one such particular plant in Germany that has an annual handling capacity of about 10,000 tons per year. So it's important just to repeat myself that once we start now using this kind of technologies, that we are very considerate to the environment, and this is something that is very important to both Fronius and BYD. So in terms of differential characteristics, what makes the lithium-ion batteries stand out? We're talking about the depth of discharge here, and as we have already mentioned, comparing to gel or lead acid batteries, we have a very good depth of discharge with lithium iron phosphate batteries of 80%. And therefore, it means the usable battery capacity for lithium iron phosphate is much better compared to lead acid. Another key differentiator in terms of characteristics would be the energy density. And the energy density here, we can talk about the volumetric energy density or the mass energy density. So in this particular case, we are looking at the volume energy density, where we are comparing a volume energy density of about 50 to 90 watt hours per liter in a lead acid battery, in contrast to a lithium iron phosphate chemistry, where we can deliver up to 600 watt hours per liter of this battery. So therefore here you can also see that the argument for going for lithium iron phosphate batteries is very, very strong when looking at the energy density. In terms of size and storage, also these are very, very critical, depending also on the kind of application you have. So in terms of weight and size, most gel or lead acid batteries are usually 10 times the equivalent of a lithium ion storage capacity. And if you look at lithium iron phosphate, in addition to the very good energy density, then in terms of size, it's just at about a tenth of a similar lead acid battery. Charging time, already mentioned by my colleague Mohammed at the beginning. So we have relatively long charging times for lead acid batteries. And therefore, it means also that the efficiency of charging for lead acid is much lower than the efficiency of charging, or the energy absorption rate is much lower than compared to lithium iron phosphates, in which case we might require something between 3 hours or even low to a few minutes, depending on the kind of battery management system that is being used. Warranty period, of course, as mentioned before, we can see here a very big difference also in terms of the kind of warranties that manufacturers are willing to offer for both battery types. For gel and lead acid batteries, usually something like 3 to 4 years maximum. But now with improved technology on lithium iron phosphate batteries, we are able to get up to 10 years of warranty. So this actually fits very well when you're talking about applying this kind of batteries for solar applications in self-consumption systems, whereby we are designing these solar installations with a service life of something like between 25 to 30 years, depending on the local regulations. So lithium iron phosphate is winning the war for energy storage and efficiency comparing to lead acid. In terms of the lifespan or the second life application, as already mentioned, lead acid really is not known for second life application. So even when it's capable to use it, this can only be done sparingly with very, very short periods of time. But with lithium iron phosphate batteries, as we have seen the comparison when you're talking about the transition from an EV battery to a standby application battery, then we still have relatively good usable capacity in the battery that you can still benefit from for quite a number of years to come after usage in a motor vehicle. So the big question now is why lithium high voltage, not just lithium iron phosphate batteries, but why high voltage lithium iron phosphate batteries? So there are a number of points that we can highlight, and point number one would be talking about how easy it is to install these batteries. So you can start with just a few modules which are stacked to achieve the required operation voltage, depending on the inverter that you're going to connect. So if you look at the Gen 24 inverter, there is a recommendation of the minimum battery voltage that the inverter is able to work with, as well as a maximum. So this guides you in terms of what is the minimum number of modules that you need for this battery, as well as what is the maximum number of modules that you can use per Gen 24 inverter variation. So the installation effort is also minimal, and therefore this process can be done by maximum 2 technicians. So in terms of the energy density weight ratios, we have seen that lithium iron phosphate is winning. And therefore, if you are talking about installing a huge battery storage system, it will be a lot easier to do lithium iron phosphate compared to traditional battery technologies. In terms of safety, also, all active components are embedded in a secure enclosure. The BYD, HVS, I believe also HVM, have outdoor IP protection of about IP55 or thereabout, but Ivan is going to highlight that. So that ensures that all the components are well protected. Also, the inclusion of a battery management system ensures that the battery is properly managed and operated. And this is with regards to the charging and discharge processes. And this ensures that because of the BMS integrated, the optimal service life of the lithium iron phosphate battery is guaranteed. And therefore, this is one of the reasons why most or high quality lithium iron phosphate manufacturers are able to give warranty of up to 10 years on their batteries, because they are very sure of their BMS systems. If you contrast that to most other battery technologies, especially lead acid, we can see that they rely on external state of charge or LVD management components, maybe charge regulators or the internal algorithm in an inverter charger. Another key point that you can look at and has a huge effect on which battery to choose is the high efficiency of lithium-ion phosphate batteries. So the power conversion round trip, which you're talking about now, the production from the PV system into the battery and then the load, is something that is very important to look at. So for low voltage battery system, these are mostly done or connected to transformer-based inverters, hybrid inverters. And therefore, it means because of a transformer inside the inverter is not as efficient as when you're talking about a transformer-less inverter. So the Gen 24 inverter from Fronius is transformer-less, and therefore you can achieve a very high efficiency of up to 98%. Very good hybrid inverters when you're talking about conversion of DC power stored in the batteries to AC for application into the loads. We would have a best case scenario of about 94% or thereabout. So in this illustration here, we can briefly talk about the different processes of energy utilization and therefore contrast the efficiency between a low voltage battery system and a high voltage battery system. So high efficiency would eventually mean that you borrow less expensive grid power over the design life of the system. And this is especially true for self-consumption systems. And therefore, you get better energy independence. And because of better energy independence, the return on investment comparatively for a system with high efficiency, those figures for return on investment are much better. So looking at this scenario, we have a PV system that is connected to an inverter and a battery system, as well as a load that is consuming, whether it's direct conversion from DC to AC from the inverter to the loads, or as a process that is involving a DC-DC conversion here for charging the battery, and then a DC to AC conversion when we are feeding the power stored in the batteries to the loads. In the red font here, we are talking about the Fronius Gen 24 inverter in combination with a BYD battery system. And you can see that the conversion from PV to the load is about 98% efficiency. Comparing that to an equivalent hybrid inverter would give us about 97% efficiency. When you're charging the battery from the PV through the inverter, our combination between the Gen 24 and the BYD can yield as much as 95%, whereas the closest hybrid configuration inverter connected with a low voltage battery system would yield just about 93% efficiency. On the flip side, when you take this power from the battery, energy stored in the battery to feed the loads, that conversion in the Gen 24 and BYD, because the Gen 24 is a transformer-less inverter, we get a much higher efficiency because actually the conversion by the MPPT is integrated in the Gen 24 inverter can go to up to 99.99%. But the closest inverter that is hybrid configuration with a transformer connected to a low voltage battery system would yield maximum 94% efficiency in this case. What does this mean in terms of energy delivered by the two different systems? So the low voltage loud trip efficiency is coming to about 94%. And in contrast to that, if you're talking about a high voltage loud trip efficiency, is coming to 97%. In terms of a practical application, if we have a 10 kilowatt peak PV installation, this could deliver theoretically on average about 60 kilowatt hours if you consider 6 hours of sunlight. With a low voltage battery combo, then taking care of this efficiency of 94%, we have a delivered energy output of about 56.4 kilowatt hours, but a high voltage battery combo is delivering something like 58.2 kilowatt hours. So on a daily basis, there is a difference in terms of energy delivered of about 1.8 kilowatt hours. And then if we are to extrapolate this over a period of 1 year, we are talking about a difference between the two battery configurations, low voltage, high voltage, of about 477 kilowatt hours. Now, talking about the service lifespan of about 25 years of this system, you can see the figure in terms of the energy delivered, the difference is quite huge. And therefore the question begs, where is the value? So you have to consider the cost of energy from the grid as well as on supply to be able to see which system, whether low voltage or high voltage, is delivering more value to you. But definitely in this case, the high voltage battery combo is much better. So looking at these figures, we can easily say that a battery is not just a battery, and we have a perfect Gen 24 Plus and BYD combo that is going to guarantee you maximum independence as far as self-sufficiency of energy is concerned. So, and at this point, I think I've come to the end of the second part of the presentation. I'll now be heading to our colleague from AfriPlus to be able to share with us the details regarding the BYD battery availabilities and so forth. Ivan, if you can take over from here.
Thanks, David. Hi, everyone. My name's Ivan. I'm the Tech Support Manager for AfriPlus, and AfriPlus is the official service partner for BYD batteries in the Southern African region. Joining us today is Khan, who's the Regional Business Director for AfriPlus in the Southern African region. And if you have any questions, please pop them in the questions tab, and we'll answer them as soon as we can. And there's also the chat section for those who'd like to chat. So a little table of contents of what we're going to be covering today. We've been introducing who BYD is and also why choose BYD. We'll be introducing the new BYD premium battery range, and then also we're going to cover a little bit of sizing inverters and batteries, and a little bit of installing, specifically with the HV side, and then we'll just cover who is AfriPlus and then a little Q&A session at the end. So who is BYD? BYD is a global leader in electronics, lithium batteries, electric passenger vehicles, electric commercial vehicles, and rail transit. And the company was founded in 1995, employs over 250,000 people, and it's got a company revenue of about $20 billion in 2018, and it's produced about 250,000 electric vehicles. Warren Buffett is also a keen shareholder in BYD. Warren Buffett sees the future of lithium batteries and BYD in that arena. So another good reason to choose BYD, BYD's got a long history of manufacturing commercial electric vehicles and passenger electric vehicles. The same cells that are used in the storage solutions from BYD are used in the electric vehicles and the electric buses, and they've been on the road thoroughly, some of them for up to 10 years, so these cells have been thoroughly tested. In many cities around the world, it's actually illegal to have petrol and diesel public transport vehicles. And so here we can see, I believe this is Shenzhen. These are all BYD electric taxis, and there's electric taxis as far as the eye can see. And some of these vehicles have been on the road for 10 years. So these cells have been thoroughly tested in real world environments. Speaking of safety, because these cells are used in electric vehicles, they're tested to the safety standards for electric vehicles. So here we can see a nail puncture test, which is possibly one of the worst things that can happen to a battery, and they're testing for thermal runaway to see if the battery is safe. So here the cell passes with no problems. And here we can see the roasting test. They're busy checking for thermal runaway, and it passes no problems. And here we can see the crush test. So the cells are crushed with 100 tons of force. So this is not something that would generally happen in a BYD storage environment, but it's good to know that these cells are tested to the highest safety standards. Here we can see some of the cells in the manufacturing process. So on our left, we've got some of these cells, and it's interesting to note that there are the connectors, and there's no screws or anything to hold the bus bars to those connectors. the connectors actually laser welded there. So they always make a good join there that never comes apart. And here we can see the robotics in our factory. Another good reason to use BYD is vertical integration. BYD's got a strong say in every step of the manufacturing process of the cells, from the sourcing of the materials research and development. BYD has a very strong hand in every step of the way. The BMS is manufactured in-house, all the R&D is done in-house, and this results in a really high quality product. And here's the new BYD range. On our left, we've got the HVS HVM series. Only the HVS will be coming to Southern Africa at the moment. This is a high voltage battery, and it's a modular type battery. So you've got your base, your modules, and your top box on the top where all your connections happen. Next, we've got the LVS, which is a low voltage 48 volt battery. It's a modular battery, a tower design. You've got your base, your modules, and your top box. Both tower designs are IP55. Next, we've got the LVL. This is a 15.4 kilowatt unit, and your modules and your LVS are 4 kilowatts each, and your modules on your HVM, I think they're about 2.5 or 2.76 each, depending on which, if you're using HVS or HVM. So there's the LVL, it's 15.4. This is very suitable for your larger low voltage installations, where you perhaps have a Victron Fronius combo. And lastly, we've got our commercial range. Here's our family replacement guide to show which batteries replace which. So here we've got the Gen 2 HV, and the HVS and HVM are direct replacement for that. And here we've got the LVS, which is a direct replacement for the old B-Box Pro, which you didn't get very much of those, the LV ones, but you got a lot of the BYD 2.5s. Those were very common. And last, we've got our LVL 15.4, which is a direct replacement for the old 13.8. The advantages of the new BYD Premium Series: the modular tower design is IP55. It's very quick to install. There's no modular addressing that you have to do with the previous generations, and there's no cables that you have to put in between the modules. They stack on top of each other, and no additional cabling is needed. You also have very good energy density relative to your floor space. Other additional improvements are online monitoring, better cold weather performance, and the latest safety certifications. Here we can see a close-up of your tower design. You can see your base, your modules, and your top box. It's got a very easy-to-use button with a good LED status indicator to indicate any errors. Very quick and easy to install locking system, and it's got very good energy density and a dedicated area for all your connections. Here we can see your BYD LVS. It's scalable from 4 kilowatts all the way up to 256 kilowatt hours. It's a low voltage system, 51.2 volts, LFP, cobalt free. And here you can see it's easy to extend at any time. Here's a little data sheet extract. If you're going to put one tower in, you can stack it 6 high, but if you're putting several towers in parallel, you can only stack them 4 high. And here's some sort of little data sheet extracts. Here we can see as you add your additional batteries, your max output count goes up, but it hits its maximum at 4 towers. Here we can see you've got a very small footprint here, 640 mils wide and 300 mils deep, giving a nice compact area for your battery installation. And you do need 1 PDU per battery bank. The other nice thing is the cold weather performance. The batteries only derate at 5 degrees centigrade, and so you've got a full power range from 5 degrees centigrade to 50 degrees centigrade, and it will work below 5 degrees all the way down to -10. So the cold weather performance of these batteries is really quite remarkable. Here we've got some LVL datasheet extracts. It's parallel all the way up to nearly a megawatt. It's also the LFP design, and you can stack these one on top of each other. So on a 650 wide by 575 deep, you can have, and 1 meter high, you can have 30 kilowatt hours in that area. A few little datasheet extracts. There's our space, 650 by 575. And if you put two on top of each other, you have a 1 meter high, 30 kilowatt hour tower. And you also need one external BMU. Here you can see some practical applications of the Fronius Victron combo. And here's more of those in Nairobi, Kenya. And here we have the new HVS. The high voltage BYD premium battery is, it's quite an exciting space to watch because high voltage isn't very popular in South Africa at the moment. And I'm sure as more installers get more familiar with it, more and more people are going to start installing. The HVS is scalable from 5.1 kilowatts up to 38.4. Also the LFP design, and it's also got no wires in between any of your modules. They're all plug and play. They're basically large blocks of Lego, electrical Lego. And you can extend them at any time. So here we've got some datasheet extracts. The thing I'd like to really sort of explain a little bit is the difference in the practical applications of installing the batteries relative to low voltage. So your modules, when you put them in your tower, are going to be in series rather than parallel. So each one of these modules on the HVS has a voltage of about 100 volts. And because you're putting them on top of each other in series, as you put each extra module on, your voltage goes up. So with 2 modules, you've got about 200 volts battery voltage. On 3 modules, you've got about 300 volts. On 4 modules, about 400, and on 5, about 500. So in terms of how this affects installations and how you deal with these batteries, these voltages are very similar to your solar voltages, and your currents are also fairly low, and these can also be handled by 6 square wires. So in terms of the practical applications of installing these batteries, they're very similar to your solar installations, your panel installations. They're similar in voltage and similar in current. The big difference there is the short circuit, where you can short circuit your solar panels and you have your short circuit voltage. It's best not to short circuit the batteries. And also you can see it's got a very good energy density ratio. It's got a very small footprint and with a lot of energy in that footprint. Here we can see a summary of the properties of the new premium range. Here we can see the LVS and HVS are both IP55. Good cold weather performance and communications. It's got CAN bus and RS485 and online monitoring. The warranty is 10 years. And when installing, it's best to check the compatibility lists to see which batteries are compatible with which inverters in terms of sizes and voltages. Here's a little summary of battery sizing. It's very important to get the right battery size, especially in the Southern African region, because typically in this region, your batteries are used primarily for backup purposes, and then cycling the power with solar is used as a cost-saving exercise. So it's very important to get the right amount of batteries there to ensure you have the right amount of backup power. And here we can see the two Fronius Gen 24 Plus inverters. And here you can see the Primo Gen 24 Plus is single phase. You get everything from 3 kilowatts to 6 kilowatts. And it's IP66. So this lends a lot of flexibility into where you can install it, especially if your battery is also IP55. We've got our Gen 24 Plus, which is 3-phase inverters. You get the 6 to 8 to 10. And these are also IP66. In terms of compatibility, so with the CMO Gen 24 Plus, you can use the HVS 5.1 7.7 and 10.2, and the Primo will be the compatibility for the Primo will be released soon. And here we can see the this is the minimum amount of battery energy you need to ensure that you have full backup power on your inverter. So please have a look at this table to ensure that when, supposing you install a 5 kilowatt inverter and you want 5 kilowatts of backup power out of it, you just have to make sure you've got the right amount of batteries attached to the inverter. Some practical applications of the tower design. So when you're putting HVS towers in parallel to increase the size of your battery bank, you must always ensure that you have the same number of modules in each tower. And you must always make sure that the types of the modules are all the same. The HVS and HVM have the same box module, but they've got the difference is they've got either a 1 number on them or a 2 number. It's very important not to mix any HVS with HVM in any bank. And here we can see just a few examples of how to install it. Here, the HVS is designed to be mounted next to a wall. So you put your base down, you make sure your base is level, and then you add your battery modules on top of your base. And these modules, sometimes it takes longer to unpack them than to actually put them in a stack. They really are like electrical Lego. And here we can see the top box. We just mount it to the wall to ensure that it's safely attached. And here we have a dedicated area for all of the connections, and that's where the battery connections and the communications cables go. Next is connecting the inverter. These are just extracts from various manuals. It's always best to refer to the installation manuals for the full guide on how to do it, but I'm just giving people an idea of how to install. And here we've got the battery cables. Because it's a high voltage system, you're actually using smaller cables. So for instance, on a 10 kilowatt system, your cables are only 10 millimeters squared, and there's only 2 cables. So that's the other advantage of the high voltage systems, is you have smaller cables to deal with, which makes things easier to install. And here's just an example of the communications on both sides, on the inverter and the battery. Our batteries are commissioned with an app, so it's available on Google Play and the App Store. And here's just a few examples of the installation guide. And here we've got a real-world photo of a Fronius Gen 24 installation and a Fronius inverter. And here we can see our HVS batteries. And this is installed outdoors. I do believe this is in Europe. And here we've just got photos of the Gen 24 and the HVS batteries. Just a little quick explanation on who AFRI+ is. AFRI+ is official service partner for BYD and the BYD lithium batteries in the Southern African region. And our goals are to provide quality technical support and quality battery training to installers and to service warranties. You're welcome to contact us with the details below. Everyone will be getting a copy of the PDF for reference and for links. And so, frequently asked questions. So we quite often get asked, why is BYD launching a new generation of products? And there are various improvements to the battery, such as online monitoring, auto addressing, and a few other reasons. And it was really time to develop a new generation of batteries. And if anyone has trouble finding any BYD HV batteries, please let us know and we'll be able to point you in the right direction. You can expand the old generation of batteries if anyone has, so please contact us on the details below. And if anyone's got any technical issues, the best thing to do is contact your installer, and if he has any problems, he can contact us directly. So, and there will be more webinars, so please stay tuned. And here's some useful web links. Like I said, everyone will get a copy of the presentation via PDF, so you will be able to click on these. And now, if we can just ask a poll of if anyone has installed any of these batteries. I'll give it sort of 60 seconds. And then we'll move to the Q&A session. I'd like to thank everyone for attending, and thank you very much for having me. I'm going to be closing the poll soon. I'll be handing it back over to David. And Fronius, thank you very much for having us on your webinar.
All right, so thank you so much, Ivan, for the third part of the presentation regarding BYD batteries. So this brings us closer to the end of our webinar for today. But before we end, we would like to share a little bit more information regarding different topics, especially now that we're talking about energy storage systems. So in terms of further information that we can give you from Fronius, you can go to the Fronius website. There are a lot of resources for our installers. Also, in terms of training and other useful tutorials, we have a lot of how to do videos that we have listed or posted in YouTube. Also, a lot of how to install kind of literature in the Fronius website. As already has been mentioned by Ivan, if you are looking for these HVS batteries from BYD, please get in touch with your normal distribution channel, and we are going to be very happy to point you to the possible sources in the different regions of Africa. So at this point, I'd just like to highlight that we have 3 representatives from Fronius, Mohamed Sidat in Southern Africa, Cyprian Okolo in West Africa, based in Lagos, Nigeria, and myself in Nairobi, Kenya. So we have our contact details here. So if you have any further questions on the topic for high voltage battery systems or even other Fronius related topics, we are very happy to speak to you at any time. So I don't know if we have any sort of open questions that we can attend to. Cyprian?
Yes, thank you, Mo. David, just one question here. I believe that Mr. Khan has already attended to it, but just for the other attendees' benefit, the question is, are the lithium batteries now transported by air freight? So, Khan, if you don't mind, you can turn up your mic and respond so that other attendees can just hear you.
Hi. Thanks for the question. Currently, most of our logistic in Southern Africa or nearby country are all transported by road freight. We haven't really had. We have a small inquiry, but on the air freight because of very expensive. Not most people don't do it. And last time I checked, was not allowed. Wasn't allowed on these large lithium batteries. But again, like I said, I will just reply on that message is things might have changed a bit. I think the best thing is to maybe find out from if you have a logistic partner that you used, an agent that your company that work with. I think it's best check with them if they need any from your country or for your side of the country that anything has changed from in terms of legislation or policy. And if you don't have any, and if you need anything that needs to send from South Africa or Southern Africa to wherever your location is, maybe drop us an email. We can inquire from our logistic partner to maybe assist you on that. Cool. Thank you very much.
Okay, thanks a lot for your answer. Yeah, so just in case, if you still have any question, if you think about any question afterwards, you can just reach us via our contact details, and of course we will get back to you via email. So I'd want to at this point thank Mr. Khan and Ivan for coming on the platform and giving us a wealth of information from BYD. Thanks a lot, Mohammed Sidat and David Mwangi. It was indeed a pleasure having you around to render this presentation. And thanks to the attendees for staying tuned and following us through this presentation. So we all hope you got all the information you were looking for, and we're all educated in this for this particular topic that you presented. So from me and the rest of the guys, stay tuned until next week when we'll come you away with another topic for the presentation. So thanks a lot, guys. It was indeed a pleasure having you.
All right. Goodbye.
Yeah, bye.
Goodbye.
Thanks, everyone. Keep well.
Yep. Thank you. Bye.